Hello everyone, welcome to the second lecture of Amplitude Modulation. In my first video, I was discussing about modulation technique, why it is used and why it is necessary. Now in this video, I am discussing about amplitude modulation in detail. So without any further delay, let's get started. In amplitude modulation, let us take a message signal is empty. This is our message signal. Now we know that for modulating this signal, we need a carrier signal. So let carrier signal CT is AC cos 2 pi FCT. The general expression of amplitude modulation S of AMT. This is the modulating signal S of AMT AC 1 plus KAMT cos 2 pi FCT. This is the general expression of amplitude modulation. Now there is here introduce a new term Ka. What is Ka? Ka is amplitude sensitivity of amplitude modulator. Okay. Let's call it as equation number 1. If we expand this expression, what we get? S of AMT is AC cos 2 pi FCT plus AC K MT cos 2 pi FCT. From this expression, one important thing to note that in our modulating signal, extra carrier signal is added. Due to this, it requires large bandwidth because in place of our message signal, we send extra carrier signal. This is carrier and this is modulating signal. From this expression, we can write this as CT plus AC cos 2 pi FCT is also written as CT, K, CT, MT, S of AMT. This is the another expression of amplitude modulation. Now let's draw the spectrum analysis of this expression. Suppose this is our message signal MT and its frequency domain representation is this minus omega to omega 0. Okay. So the spectrum analysis of amplitude modulation is like this. This is FC, this is minus FC, this is FC plus omega, this is FC minus omega, this is minus FC minus omega, and this is minus FC plus omega. From where I get this? With the help of Fourier transform. In my previous video, I was telling about the Fourier transform of AC cos 2 pi FCT is what? AC by 2 del f minus fc plus del f plus fc. With the help of this expression I get this. Okay, this is called USB. What is USB? This is upper sideband. This is LSB, lower sideband. LSB, USB. Okay. Now we calculate the bandwidth required to modulate this message signal. The definition of bandwidth is highest positive frequency minus lowest positive frequency. Highest positive frequency minus lowest positive frequency. So bandwidth of highest positive frequency is what? Fc plus omega. Minus lowest positive frequency, Fc minus omega. Due to this sign, this will replace as plus. Fc to Fc cancel, 2 omega. Okay. Omega is what? Our message frequency. So we can say that the bandwidth of AM signal is 2 into message frequency. Whatever the frequency used in our message signal will require double times of bandwidth to modulate this signal. Now the next point is single tone AM. We can transmit only one signal or we can transmit more than one signal in the same channel. When we transmit one signal in the channel, then it is a single tone modulation, and more than one, then it is the multi-tone modulation. Single tone AM. As our carrier signal is AC cos 2 pi FCT, let our message signal MT is AM cos 2 pi FMT. Okay, FM is our message frequency. We use only one message signal, message frequency, so it is the single tone modulation. The general expression of AM is what? S of AMT is AC 1 plus K MT cos 2 pi FCT. Put the value of this MT in this equation. What we get? 1 plus K AM cos 2 pi FMT cos 2 pi FCT. Okay? Now, let Kam is equals to mu. Mu is what? The modulation index. What is this? That I will discuss after some time. This is modulation index. So S of AMT AC 1 plus mu cos 2 pi FMT cos 2 pi FCT. If we further solve this equation, AC cos 2 pi FCT plus AC mu cos 2 pi FMT cos 2 pi FCT. Clear? Okay, use trigonometry equation here, cos A cos B. So two cos A cos B. Use this formula to solve this expression. What we get? S of AMT is AC cos 2 pi FCT plus AC mu by 2 cos 2 pi fc minus fmt plus ac mu by 2 cos 2 pi fc plus fmt, that is cos a plus cos b by 2 plus cos a minus b by 2. Okay, cos a plus b by 2 cos a minus b by 2. With the help of this equation, what is this? This is carrier. Fc minus Fm represent lower side band, Fc plus Fm represent upper side band. This is the general expression of single tone AM, right? In next topic, let us discuss several parameters of amplitude modulation. There are several parameters are there in which we can calculate the power or efficiency or voltage required to transmit our signal or modulate our signal. First is transmitting power. The general expression of transmitting power PT is PC 1 plus mu square by 2. PT is transmitting power, PC is carrier power, mu is the modulation index. From where I get the whole definition is derivation is there. If you want derivation also, so do comment in the comment box. But derivation is not much important. You have to focus numerical based on this expression, which is more important. The second is efficiency. What is the efficiency of amplitude modulation? Amplitude modulation efficiency of sideband power with the ratio of total power, which is given by mu square upon 2 plus mu square. Okay. The third parameter is current IT, transmitting current. IT is IC 1 plus mu square by 2 under root. In the same way, transmitting voltage VT is VC 1 plus mu square by 2 under root. This is very important parameter of amplitude modulation. You have to solve numerical based on this expression. Okay. Now our next topic is multi-tone modulation, in which we are transmitting more than one frequency of our message signal. We know that our carrier signal is AC, cos 2 pi FCT, and let our message signal in multi-tone modulation we use more than one frequency. So let AM is AM1 cos 2 pi FM1T plus AM2 cos 2 pi FM2T, and we follow the same rule as we follow in the single tone modulation derivation. What is that? S of AMT is AC 1 plus KMT cos 2 pi KMT cos 2 pi FCT. Put the value of MT from equation number 1. AC 1 plus KAM1 cos 2 pi FM1T plus KAM2 cos 2 pi FM2T into cos 2 pi FCT. In the previous derivation, I was telling that KAM is mu. So in the same way, we can also call KAM1 is mu1, Kam2 is mu2. So we can write this expression like this: AC1 plus mu1 cos 2 pi Fm1t plus mu2 cos 2 pi Fm2t cos 2 pi FCT, right? This is the general expression of multi-tone modulation. You can further expand this expression to find USV and LSV, but that is not much necessary. Okay, here I get mu1 and mu2. So we can calculate the power in terms of mu1 and mu2 also. Let me explain further for this. Like the general expression of power is PT equals to PC 1 plus mu square by 2. This is valid only if only one frequency component present is there. Okay, and if more than one frequency component means in multi-tone modulation, this is not valid, because here we have more than one frequency component, so we have more than one modulation index. So if more than one modulation index is present, that is mu1, mu2, mu3 and so on, then to solve this equation we use this formula: mu is equals to mu1 square plus mu2 square and so on under root. So in multi-tone modulation, in place of mu, we replace this by mu t, total mu, okay, modulation index. And you can also, like current is IT is equals to IC 1 plus mu t square by 2. You can also check out the expression of voltage also. Now our next point is the generation and demodulation of amplitude modulation. How it is generated and how it is demodulated. But before that, we will solve some numerical problem based on the parameters of amplitude modulation, right? So we will discuss in detail in our next video. We will solve several gate examination question and several engineering service examination question based on this topic. So that's it for today. Thank you. Thanks for watching this video.